My name is Mahmoud Wagih. I'm an academic at the University of Glasgow and I lead the Green Electronics Lab. So the Green Electronics Lab is actually a green RF-enabled electronics lab, and by RF I mean radio frequency or just wireless devices. It means that we research ways that wireless technologies could help us make standard electronics more sustainable, more green. It could be by new applications or by simply substituting materials, and that's what gave birth to the spin-out RX Watt. So existing electronics are not designed to be sustainable, they're just designed to perform one functionality. One of the areas of our research is how we use wireless technologies, for example, to substitute existing components, basically do more with less. For example, by using the wireless signals, which carry a small amount of power alongside data to charge electronics, that could help us extend the life of batteries. It could help us have battery-free systems. It also allowed us to move away from the critical raw materials which go into manufacturing the batteries. Now, the challenge with wireless power is that we're dealing with very small power levels. That's still suitable for applications like sensors, that could be in industrial applications, it could be in vehicular monitoring. So when we started researching this technology, we were approached by multiple industry partners. We were told that the amount of power that we're delivering could solve a problem in environments where there is absolutely no other source of energy. One good example is train carriages. Underneath the train carriages, there are lots of blind spots where there's no energy. There are lots of moving parts that are prone to failures, for example, brakes and axles. And the sensor data that can only be achieved when you wireless power these sensors is extremely valuable for reducing the maintenance bills and for making these vehicles a lot more sustainable and safer. Another example of inaccessible environments is the human body. Radio waves has this ability to penetrate through the skin, penetrate through tissue, and deliver power to medical devices that are buried deep inside the human body. For example, pacemakers. You could recharge these, you avoid the surgery that's needed to replace the battery. We're now even working on implants that deliver on-demand drugs using optical and electrical control, all using radio waves for power delivery. So RX Watt was incorporated in 2023, and one of the main objectives there was to translate a lot of the findings that we've been developing in the lab. We'd already worked with industry and government partners, and it was just a matter of finding those end users and scaling this technology out of the lab. With the spin-out in place, it's effectively a vehicle for translating knowledge from what gets developed in the lab, from those emerging and exciting opportunities, to something that could immediately get into the hand of customers and be deployed. In the next 5 years, my hope is to see a lot of the RF technologies, the wireless devices that we're building, finding new applications that reduce our demand of electronic devices, that help us make the electronic industry more sustainable. It's in a way what would help us reduce the demand for new materials, reduce our carbon emissions, and deliver the same quality of service to end users, to consumers, while not increasing our environmental footprint.